All right, welcome. Today, we're moving past just building objects and into the world of designing really powerful, elegant software systems. We're going to do that by unlocking a developer's toolkit with three core ideas: inheritance, polymorphism, and abstraction. Let's dive in. So you get the basics, right? You can write a class, you can create an object from it, no problem. But what happens when your project explodes from, say, 10 objects to 1,000? How do you stop your code from turning into a complete tangled mess that nobody can understand? That's the real challenge we're going to tackle. Okay, first tool up in our kit: inheritance. You should think of this as the ultimate way to reuse code and keep things organized. It's how we create these logical kind of family trees for our code, which helps us avoid writing the same thing over and over again. At its core, inheritance is all about creating what we call an is-a relationship. A dog is an animal, a car is a vehicle. You get the idea. The new class, the subclass, it just automatically gets all the features of its parent, the superclass. And that means you only have to write that common code one single time. Let's make this real. So, over here on the left, we've got a general animal class. This is our blueprint, right? It's got the stuff all animals do, like eat and sleep. Now, look to the right. We create a more specific dog class. By using inheritance, our dog gets all those animal behaviors for free. And then we can add its own special thing like bark. See? We've reused the blueprint and just added our own little twist. Okay, that's cool. But what if our dog needs to eat a little differently than a generic animal? Maybe it eats special dog food. Well, for that, we use something called method overriding. We just give the eat method inside the dog class its own unique implementation. And we often use that @override annotation you see there. It's like a helpful little flag for us and the computer, making it super clear what we're doing. And now for our second tool, which actually builds right on top of inheritance. This is polymorphism. And honestly, this is where our code starts to get really flexible. The word itself just means many forms, and you're about to see how it lets us control a ton of different objects with just a single command. So here's the magic of polymorphism. It lets us treat a dog object as if it were just a generic animal object. We can write our code to work with animal, and then, at the very last second when the code actually runs, the system is smart enough to figure out, oh, wait, this is a dog, so I should use the special dog version of this method. And this is where it all clicks. So check this out. Imagine you create a list that's built to hold animal objects. You can throw a dog into that list, a cat, any other kind of animal subclass. They can all live together. Then you can just loop through the list and tell each one animal.eat. You don't have to check if it's a dog or a cat. The system automatically calls the correct, specific eat method for each one. That's runtime polymorphism, and it's incredibly clean. Okay, our third and final tool for today is abstraction. So if inheritance is about reusing code and polymorphism is about being flexible, then abstraction is all about making things simple and safe by hiding all the messy details. The perfect way to think about this is just driving a car. You get in, you use the steering wheel and the pedals. You don't need to know anything about the engine's combustion cycle or how the transmission works just to get where you're going. Abstraction in our code does the exact same thing. It gives us a simple set of controls and hides all the complex machinery working underneath. So yeah, abstraction is all about defining what an object can do while totally hiding how it gets it done. And in our code, we usually pull this off in two main ways: with abstract classes, which are like a partial blueprint, and with interfaces, which are more like a complete contract of behaviors. This table really breaks down the key differences. So first thing, you can't create an instance of either one directly. But look at the methods. An abstract class can be a mix of concrete methods that actually have code and abstract ones that don't. An interface, though, is traditionally a pure contract. It just lists what you have to do. And here's the really critical difference. A class can only inherit from one abstract class, but it can implement many interfaces. That gives you an incredible amount of flexibility when you're designing your system. All right, Theory is great, but let's put it all together and see how this stuff works in the real world. We're going to design a super simple banking system, and you'll see how inheritance, polymorphism, and abstraction aren't just academic ideas, they're totally essential.
So first, we use abstraction. We create an abstract class called account. It defines the stuff that all accounts need, like a balance and an account number. But we declare the withdraw method as abstract. Why? Because a savings account and a checking account handle withdrawals differently. They have different rules. Then we use inheritance. Our savings account and checking account classes both extend the account class, and each one provides its own specific, concrete rules for how withdrawal should work.
And now, this is where the magic of polymorphism comes in. We can create a single list of account objects. And in that one list, we can toss in both savings account objects and checking account objects. They can all exist together. Then, when we loop through and call account.withdraw, polymorphism guarantees that the correct specialized logic for each specific account type gets executed all automatically. It's clean, it's efficient, and it is just so powerful. So, there you have it. You've just added 3 of the most powerful tools in object-oriented programming to your personal toolkit. Let's do one final, super fast recap of what each one brings to the table, just to make sure it sticks. Just remember it like this. Inheritance gives you reusability, letting you build on code you've already written. Polymorphism gives you flexibility, letting one command work on many different types of objects. And abstraction gives you simplicity by hiding all the messy complexity. Put them all together, and that's how you build systems that are robust, maintainable, and easy to change. You now have the fundamental patterns to truly manage software complexity. You're not just building objects anymore. You're ready to architect entire systems. So the only real question left is, what elegant system are you going to build?